Awesome. So thank you very much for all being here. We are going to talk about how to build a multi-agent role-playing game master with Strands. But first, I just want to make sure who in the room doesn't know what is a role-playing game? Okay. Yeah, I'll still, so for the few of you that don't know, I'll still do a little introduction about what role-playing games are. Specifically this one, so you have role-playing games in video games, but you also have tabletop role-playing games, which are games that historically, I would say, because it really changed with numerical ages, but historically, all of the players are around a table and they play together on, like, they have character sheets, they have their names and stats of all of their characters that they play. And there is what we call a game master. And the game master has the responsibility of creating an experience for the players. The game master knows everything about the game. They usually have read a thick book of rules that are like 400 pages that describes the dynamics of the world. So like known tabletop role-playing games would be Dungeons and Dragons. Maybe you've heard of it. There's like a Netflix TV show called
Stranger Things.
Yeah, Stranger Things, where like the kids play that game. So basically, yeah, so I play this game too in my like personal life, and for all of my projects in AI, I like to try something with a project that I really like, I'm passionate about. And with generative AI, it came up to me quite quickly that AI could be interesting to use for tabletop role-playing games to help game masters, or even sometimes to replace them, because the AI game master role is really important in the fact that they need to be creative. They need to be able to embark the players in a story. They need to be able to create things on the fly. They need to remember all of the rules of the game. It's really hard and really complex. So I was thinking maybe AI can help with this, because AI can be very creative. They can do improvisations, but they also have knowledge bases to help them with rules and stuff like that. So before going further in the talk, I just wanted to introduce us. We're going to do this talk together with,
Hi, I'm Olivier. I'm a developer advocate at AWS.
And I'm Tiffany. I'm a senior developer advocate at AWS also in AI. Okay.
We all do AI anyway these days.
Yeah, we all do AI, yeah, true. So first, before showing you the live demo or how we're going to build the AI Game Master, first, a few things that you should know. What is an LLM? You might have heard of this. Like at this point, it's probably very easy for you as a question, but still. So an LLM stands for large language models. Basically, those are the models that they carry all of the weights that have been calculated for them to be able to talk with you. So basically, what the algorithm does is to predict the next word in a sentence, a sequence of tokens or words. This is really just what it does. And it sounds very, like, dull. But actually, if you train those LLMs with a huge amount of data, then it happens that those LLMs are actually able to create more than just a sentence, but like huge conversations. They can write books for you. They're pretty amazing today, as you know, because you might have used them already. But the limitation of LLMs is that, I don't know if you remember at the beginning of when ChatGPT came out, but the only thing you could do with it is to talk with it. And they're amazing for a conversation, but quickly people were to think, if I want an assistant, maybe I want the LLM to be able to do something for me, not just talk with it. So what are agents now? Agents are basically LLMs. They have the capacity to talk with you, but they also have the capacity to do things for you. So if you want an assistant, that not only can talk with you, but also understand your problems and things. And maybe they can do things like put an appointment into your calendar, or book a train ticket for you, or plane ticket for you, or book a restaurant or something. If you really want them to be able to do that, then you need to give them tools. And a tool can be pretty much anything. It could be a function, it could be an API, it could be a knowledge base or a database. So it can have access to a database and update the database or delete things in them. It can have access to APIs. So maybe if you want your assistant to be able to book a flight for you, then it needs to have the API call to that website. So agents, and that's the reason why we call them like that, they have agency. Not only they can talk with you, understand your context, but they can also do things for you on your behalf. And that's when it becomes really interesting. So as I said, like tools could be API, databases, functions. The way you connect your agents, so basically before having access to the tools, it's still an LLM. But if you want your LLM to be able to do things for you, you need to connect your LLM to tools through what we call MCP. MCP is a protocol. It stands for Model Context Protocol. And MCP is the equivalent of HTTP for the agents. So basically, you have maybe some of you have tried before to connect your agents with tools on your own without MCP. I mean, it was doable, but it was complex. And for every single one of your tools, then it had to be different. You needed to maintain it if you had a lot of tools, and it became quickly kind of overwhelming. And also, you were the only one that in the same time took care of your tools and in the same time took care of the agents. But connecting your agent to a tool that someone else has created was almost impossible, unless you knew that person. MCP allows you to connect your agent with any tool that anybody created. So that's really, really cool. It's like, for example, going back to your LM wanting to be able to book a flight for you on an airplane website, then let's say Air France, then Air France can create an MCP server and allow your agent, and you connect your agent to that MCP server. So your agent is able to book flights for you. And anybody can do this. So you could be the owner of your tools with your MCP servers, but you can also use others' MCP servers, so that's really cool. And one other thing is that you can connect your agents to other tools, but you can also connect your agent to other agents. That's when you have multi-agents collaborating with each other. That's how you have projects where you can have like very complex workflows where you have one agent that has access to other agents and each of them is specialized in something. So if you've played with multi-agent workflows, you might have realized that having just one agent that does a lot of things sometimes can lead to hallucinations or confusion in what the agent must do. But having different agents that are all specialized in one thing is much more efficient. So what we do now is that we connect all of those agents together so they work as a team, and that becomes pretty cool. So you can connect your agent to other agents. That's not the same protocol. For tools, it's MCP. To connect another agent, it's what we call A2A, agents to agents. So that's just another protocol. It standardizes the way you connect with other agents, the same way as MCP standardizes the way you connect your agent to tools. And of course, this used to be very complicated and convoluted, but now we have frameworks like Strands Agents is an SDK that is open source and helps you build, takes away all of the abstraction of this and helps you to create multi-agentic workflows really easily in just a few lines of code. And that's why we're doing this live demo is to show you, we're going to start from scratch and show you how you can build a multi-agentic workflow with A2A and MCP. Of course, so Strands Agent does support MCP and A2A, and we'll show you how very easily you can connect your agents to tools and other agents. So this is what we're going to build.
I just wanted to add, because you had the logos here. So Strands Agents works in Python and TypeScript for now. We're going to do the demo in Python, but if you do TypeScript, you can also use it. There's a version for it.
So that's what we're going to code today. We're going to have a game master. So that's the game master that we are the player, and we are going to interact with that agent. That agent needs to have a lot of capacities to be able to do the game master thing. First, it'll be connected to an MCP server where we have a function that can roll dices. So just disclaimer, you usually don't do an entire MCP server just for one simple function, but it's just to show you how we do this, and then you can expand onto your own use case. So we'll have a MCP server with a function to roll dices. So the end game master can, if you've never played role-playing games, this is how the game master decides the fate of a decision or something. There's usually a D20 dice like those. I love to have them. There's 20 faces. You roll it. If it's 20, you succeeded. If it's 0, you failed. Anything in between is a gradient of that.
There's no 0.
Yeah, one. Like, for example, is this demo going to go well? 8. 8 is not a good roll, so hopefully that's going to get better than this. But so we have the roll dice. We're gonna have, I'll put this here. We also have the rule agent. So the rule agent is specialized in the rules of the game. So we'll have a knowledge base. We don't create it in the live demo, but we have a knowledge base where we vectorized all of the rules of the game. And the rule agent can kind of query the knowledge base to make sure that we are compliant with the dynamics of the game. And we have another agent called the character agent that has access to a database of characters. So whenever during the game master decides to create a new character on the fly, then it can ask the character agent to manage this and put this in the database. All right, let's start.
Yep, too far.
Yeah, sorry. Right.
There you
go. Okay. Yes. All right, so as I told you, not lying, this is very simple to create an agent today. You just have to import the agent class.
Is it big enough?
Is it big enough?
Is it big enough, the font? Do you see it? Good? Okay.
Okay. So you just have to, from the Strands tool, you just have to do a pip install Strands library, and then you can go Strands-agent, I think. And once you're in your code, you do a virtual environment that you activate. We are in this virtual environment. Now you can import your agent class, instantiate it, and just send it a query like, hi, Tunis, how are you? And just launching this, we should have a response if internet connection works. Okay, so what just happened here? Behind the scene, by default, if you don't mention any model specifically, by default, the Strands library will go and try to do this call to your Bedrock account on AWS. And by default, it's Claude 3.7 or Sonnet 4.
You can print it.
Yes, true. Yeah, let's print it here. It's agent.
.model.config, yeah.
Yeah.
Anyway, by default, we're gonna see after this, you can use whatever model you want, but by default it's using AWS with Cloud Sonnet 4.
Cloud Sonnet 4 by default. But Strands Agents has been thought of being completely agnostic, provider agnostic. So if you go to the documentation this way, not my computer, so confused. But if you go to the documentation, user guide, and then where is model providers?
Yeah.
Here you have all of the different models you have access to. So of course you have the ones on Bedrock, but you also have access to Anthropic. If you have an API key, then you can put it here and directly call on it. Mistral AI, OpenAI. You also have Ollama, access to Ollama. So for those of you who don't know, it's a way you can have your models running locally. So for example, Olivier has Ollama locally, right?
Anyone doesn't know Ollama? Okay, Ollama basically is a tool. You just install it, and then it allows you to download hundreds, if not thousands, of open source models. If you go on there's a website we can show after. Yeah, the website, if you go on the models, so installing is just like one line, and then you have access to, I mean, you can scroll forever almost, all these models. And if you just go on one, click on one model, and then you just like Ollama run, and it's going to download the model, which could be 19 gigabytes, 290 gigabytes, so be careful, or just like a couple of 100 megabytes. We have like big and small models, but like they download it and then run on your computer, so no cloud needed.
Yeah, so I just checked locally, Olivier has those 3 models. If, for example, I want to use that Ollama model, I can just copy and paste that piece of code from the documentation and replace it here. So you just import the model Ollama, import Ollama models. Here you create a variable where you specify the model ID. So for you, it's 3.2. And that's a good port, 11.4.34, because you have the default one, right? And then when you instantiate your agent, you just put model, Ollama model, you injected it. And if you re-ask the question, it should use the model that Olivier has locally on his machine. So you're not locked into AWS by any means. If you want to use Strands and use it with your own models, you can do it. But for the sake of that presentation, we'll just go back to using the default, right?
I can do.
Yeah, do you want to?
No, you want to continue? I'm here.
I'll just show the tool and then I'll leave you on. Yeah. So for now, we just talk to Claude 4 that is hosted on AWS infrastructure. But it's not an agent yet. It's just conversational, right? If you ask a question that is very simple, such as, what time is it? It's not going to be able to answer that question. The reason is that the model is hosted on AWS at the last stage of when it was trained and dumped there. So it has no concept of time, of geography. It doesn't know anything about where it is, what time it is. To be able to know the time, it needs tools. So we are going to create an agent now. From Strands Tools, the library, you can import. So just mentioning, you have tools that are provided by the Strands library community. So there's, where is the community tool package? So the community built-in tools, basically you just have to install Strands Agents tools. From here, you see that you have different available tools that have already been created by the community, just because some of the things that we want to do are very standard like things, so you don't have to recode it. Like you can play with memory, read and write files. You can run shell commands, run Python code, and of course there is a current time function right there. And if you want to know the details of how it's coded, then you can just click on it and you have all of the detail of how this function actually works. So going back to the code, here you just have to import the name of the function, current time, that you need. And here in the tools setting parameter, you pass the current time function. So now if I ask what time is it, it's out. Oh, Python. Yeah. Oops. Sorry, like exit. I have another keyboard at home. There it is. Okay, so now when you use that, when you have a tool and your agent has knowledge of it because you pass it into the parameters, now it knows that it needs to use the tool current time to be able to give you the time. Time zone's wrong, but you can change it.
If you ask what I'm using in Tunis, it's going to tell you.
True. Because it has general knowledge of the time zone here. So it can make the logical decision to, yeah, add an hour at a time. So there it is, how you just very quickly build an agent that has access to a built-in tool. And I'll let Olivier show you how you can do it with custom tools, because in our example, we want a dice roll function. Yeah.
Okay, cool. So we've seen how to create an agent. We're just creating an LLM, coding some tools that have been created by someone else. But I mean, the title of the talk was how to create a game master, right? So not to create a watch in that example. So if I want to say like, roll a dice of, I don't know, roll a dice. What do you think is going to answer to me now? Anyone?
Try something.
Try something?
Try to.
6?
Yeah.
Okay. Yeah, what would be the result? What is it going to say?
Try to guess.
Try to guess. I guess 4.
6.
The
Let's see. Oh, I said I don't roll dice. Okay.
We say 12.
Here's the result is
Oh,
4.
4. Oh, got it. I know how I got it is that 95% of the time it says 4. Because what? No, because not because it's cloud 4. It's only 4. No, because of the thing is we want a random dice, something from 1 to 6 in that case when you don't specify. The problem is that the LLM doesn't know how to do random functions. All it knows is the huge amount of data on which it has been trained on. And what we can expect is that on all the data it read on the internet, all the games, the rules or whatever, most of the time it must have read a 4 when someone was rolling a dice. And so, which is not what we want. We want like a proper random roll. The thing is, writing a function that can roll, like do a random, like roll dice with a number of faces, that's something we can do. That's just pure code, or you can ask an LLM to do. Generate a function that rolls a dice with a number of faces given as a string, manage errors, and write docstring. Okay, I'm being lazy. It's 2026. We have AI to write code. Nice. So here I have a function with some docstring, import random, cast into int, does a random. That's pretty cool. So writing that has nothing to do with LLM. It's just like a function. No, it would be cool to say, like Tiffany did earlier, say like, that would be a tool now. That would be amazing, right? Okay, Strands is not that amazing, but not that far from it. All I have to do is to import the tool here, put a decorator here, and say now my function is becoming a tool, which means if I call again here roll a dice, it's going to call the function roll dice and then return 1. Not great. And I can like roll left 20 is going to roll a dice of 20 faces and return something between 1 and 20, 13. And you're going to say like, roll 3d20, like 3 dice with 20 faces. And now it's going to know that it has to call 3 times the roll dice tool and then return the results, and even the total, even though it didn't ask for it. But you can see that we just create a function with this pure code and transform it into a tool that our LLM can call. The question is, how does it know that it can call this tool and what this tool does? Because I could have a lot of tools. And that's the docstring. The LLM, the agent, is going to use the docstring to know, okay, this function, this tool, roll dice with a specific number of faces. It's going to load the arguments, so he knows that it takes a number of faces as a string. So it's going to, whatever I gave him here, the 3D20, he's going to take that and call 3 times the roll dice function, which is 20 as a string. So he knows how to call it. Okay, that's good. We know how to create a tool now. We mentioned protocols earlier, because there's 2 reasons why I wouldn't want to do it like that way. The first one is that someone else at the other side of the planet, don't care, already created a tool to roll dice. I don't want to write it again. It exists already, someone did it. Second option is I'm someone nice, I want to write the tool and I want to give it away so people can use it. So if someone needs it, he can use my tool. And that's when the MCP protocol, the MCP means protocol already, but that's when MCP comes into action. The idea is that say we're going to create a new file, MCP dice. And the idea would be to have our tool not here, but behind an MCP server. So let's say we have our agent here who does basically nothing because we want it to rely on the MCP server. So I'm going to put my function here. So Strands Agents is an SDK to create agents, not MCP servers. You can connect to MCP servers or other agents, but it's here to create agents. The thing is, we have a nice library called FastMCP, which is open source, created by your community, very nice, that allows you to do a lot of things, including creating MCP servers. So I'm going to create an object here. I'm going to give it a name. So DND roll dice service, whatever. I'm going to be the host, so it's going to run on my local host, which is by default if you don't put it anyway. I'm going to give it a port on which I'm going to be able to connect to, and I have my MCP server. I'm going to run it here. And now to connect to MCP servers, you have different ways, different protocols. Either you can use like standard input-output if it runs locally. You can use SSE, which is like basically servers push messages. Never seen any MCP server running like that. Or you can use like streaming HTTP. So it's going to be like streamed through the internet. So you have to specify the transport system, streamable HTTP, which is the one I'm going to use here. So anyone on the internet should be able to access my MCP server through HTTP protocol. And so I have my MCP server, I'm running it. Last thing I need to do is the same thing we had with Strands, is say, okay, this function now is a tool. And so FastMCP works a bit like Strands. You just have to add a decorator here. I'm taking my server and I register this function as a tool. Okay? So now if I run this, I have a server running on that port. So if I open it, so FastMCP give me an endpoint on the /MCP, and you can see that my server is up and running. Okay, there's an error because I do a get on Chrome, and it is expect like an event stream, but I have my MCP server running. Now let's go back to my game master. I need to tell him that, oh, you have access to tools, but not from you, but from an MCP server. So I have imported my MCP client class, and because I'm going to connect to it through the streamable HTTP, because that's what my MCP server accepts, I also import the streamable HTTP client function. So I'm going to create a client, and which is taking like a lambda function, which is like an anonymous function. And I'm going to call the streamable HTTP client method and just give it, the URL of my MCP server. Just by doing that, I have an MCP client that is going to connect to my MCP server. And what I can do, I can say, okay, you know what? No, just that. I can take my agent here, and in the tools, I'm going to put just my MCP client. And just by doing that, it's going to know that when I call here, you're going to see that it's calling here. My MCP server has logs saying, okay, I've been requested to list the tools I have access to. So my agent now knows what tools the MCP server has access to. And we asked to roll 3 D20. And you can see that I have like 3 call to requests. 1, 2, 3. And then we can have here the 3 roll dice tool called. So now you can see that basically my agent, who has no idea how to roll dice, relied on the MCP server, called 3 times the roll dice tool there, and then prints the result on the agent. And then you can connect to many MCP servers, of course. So that's MCP. The second protocol we mentioned is agent to agent. Let's say I want to have another agent to manage characters. I'm going to say, okay, you remember how we create an agent? I import agent from Strands. I create an agent. Now, here, because I'm not going to call the agent me, but another agent is going to call it, it needs to have some information. So I'm going to give it a name, D&D character management agent, whatever. I'm going to give it a description. So the description is going to say, okay, you can create and manage Dungeons and Dragon character with a name, class, race, statistics, and background. And you can write and read files. Now, in a proper project, you would use a database. We have 15 minutes left, so let's use file. So what I'm going to do is that I'm going to import the tools file read and file write, which are based on the in the Strands tools Tiffany showed earlier. I'm going to tell my agents, okay, you have access to these tools, file read and file write. So now I have an agent, but in order to call it, I need to put it behind a A2A server so you can understand the A2A protocol. So I'm going to import the A2A server class, and I'm just going to create a A2A server object. I'm going to give it the agent that is going to run behind. So that's the agent here I just created. Oops. And then, like with the MCP server, I'm going to run it. I'm going to run it, say like, okay, you run on my localhost, and you run on port 8081, so we're not on the same port. And same thing, I can now run my agent character. So I have another agent who also could run anywhere on the internet. He's behind like a HTTP URL. And let's go back to my game master. Again, the game master doesn't know how to read file, write file, create characters, but he can rely on this other agent. So I'm going to import the A2A client to provider, which is going to allow me to connect to other agents. I'm going to A2A provider, A2A provider, and now the only thing that I have to do is like give it like a list of all the URLs of all the agents I want to connect to. So right now I have only one, but here I could have like a whole list of URLs of other agents I want to connect to. Okay, and now what I have to do is tell my agent, okay, you have access to the tools of the provider. So the tools of the provider are not the tools of the other agents. They are tools of the provider that can tell him, okay, send message to another agent, list the other agents, these kind of things. Okay, let's try. Okay, create a character named John. Okay. Who is an elf of the night. Roll the dice to generate his characteristics. Then save it in a file. So again, to generate a character and then save the character in a file. Okay. Okay, what is happening? Why don't I have my here? All right, let's try that. Let's try it. Okay, launching that. So there's a lot of things. So MCP code here. So list tools. I don't know why I have this weird glitch. It's rolling dices. Okay. Woohoo. Okay. It's going too fast. It's going too fast, and it's not doing exactly what I want. It's not doing exactly what I want because my agent here, it doesn't really know what a basically a Dungeons and Dragons character is. So what I'm going to do is I'm going to give him a system prompt. System prompt is kind of the identity card of an agent. So here I'm saying, okay, you're a D&D game master, you have access to different tools and agents, trying to orient it, say like, when you need something, go check if you have agents or like roll dice or other MCPs that you can use. Okay, let's try again. I send the request. Okay, you can see that here is getting the information from the agent. And actually, he does that by calling the tool A2A list discover agents. I say, okay, great. I found a D&D character management agent. Let me roll the dice for John's characteristics. And I was rolling the dice saying like, okay, John has 18 in strengths, has dexterity of 10, a constitution of 8, an intelligence of 12, wisdom of 12. And so it's rolling the dice here. So it's calling the MCP server. And then you can see that now I have all the ability score of John, I have to use the character agent, and it's using another tool to send a message to the agent. And you can see here that my character management agent has been triggered and has access to a tool to write files. And so it's going to call the tool, and because writing file is a bit more dangerous than getting the current time, it's asking me by default if it's okay to write something on my computer. You can bypass that with an environmental variable, because in CI/CD stuff you don't want that. By default, it's asking me. Now, if I say yes, you can see that here we have a John file, dwarf elf, with a full character sheet of Dungeons and Dragons with all the dice we rolled. He came up with like features, fighter, whatever. He created the whole character with like background stories and everything. And then you can ask, you know what can you tell me about John, about the character? Okay, the character John. Okay, it's saying everything back. And if I ask that, same way, it's going to say, okay, let me check if I have agents that manage character. So it's asking what are the agents doing. Say, great, I've seen there's a D&D character manager agent. It sends a message. You can see that this time here, what is happening is somewhere there is the tool to read a file. Should have called the file read tool somewhere. Too many logs. But it's going to read the file, John, send it back, and then I get my John character information from the file. So you can see that my Game Master agent here basically doesn't know how to do anything, but can rely on MCP servers who could be on the internet, other agents who could be on the internet to be a good Game Master. Now, we can't do the whole game in 45 minutes, but we can show you what it looks like when it's a bit more advanced. So this is a demo that you can find on GitHub that we've done, where you have the MCP server, which is exactly the same one we just built, where I have a character agent, which is almost the same one we did, except that it's not using files, but it's using database. So I have my database description here, and we just created tools to create the database. So I have a find character by name, just made it a tool, and basically the only interesting line here is the DB search. You have list all character, also this function becomes a tool. The only interesting line here is the DB all. So we just wrapped the database calls in function that became tools. We have the rules agent, which is reading the knowledge base. We just put the PDF of the Dungeons and Dragons rules, putting in a knowledge base so we can query it. And then we have the Game Master. So the Game Master is basically like a huge prompt. And the only thing we've changed here, so you can see that he has access to the two other agents. He has access to the MCP server somewhere here. So same thing we just did. The only thing we changed is that because I want to use that in a user interface, in a website. So I don't want it to like come up with like a huge string as output that I can't really do anything with. So when you create an agent, what you can do is to say, you know what, when you reply, I want you to reply with a structure output. So something I can use then in my interface. And in that case, it's going to be like a JSON. And so I'm giving it a class here, story output, and then I just define the class. Story output here, it's a response, which is a string, which is the narrative response of the Game Master. The story is making up. It has action suggestion, which is a list of strings, which are actions that the character can do in the game. Details, we don't use them. And then dice roll. Dice rolls is a list of dice output. And dice output is an object with the dice type, like a D of 6, 20, whatever. The result of the dice and the reason why we rolled the dice. I'm just telling him, don't send me like a huge text, send me something that matches this object. And so let's run that, shall we? Yes, no? Yeah. Oh, okay. Not a problem. It's not a problem. We don't really care because what is important is the...
So Olivier is going to launch all of the different services that are going to communicate to play the game. So the first one is the MCP server. And then on the second terminal, he's running the server for the character agent. Then on the third terminal, he's running the rule agent, so the agent that is specialized in the rules of the game. And the last terminal is the AI Game Master.
Wait, I'm going to have problem with ports that are the same as a demo. Okay.
So once he's launched all of those agents and services, he can go to his UI.
Where's the
Just-
delay?
Further
Okay,
right.
let's take my game master URL first here.
Yeah.
And where's my UI? Where's my Chrome? Where's my Chrome? Here. Okay. So we develop like a little interface with Tiffany so you can play. So you can say, okay, let's go with John. John is going to be a male, he's going to be whatever, half elf, he's going to be like a druid. I'm going to put the URL of my game master. My game master is using like fast API. So it's just like an API so I can create from the internet. And then I'm going to start the game. And when I start the game, what is happening, I don't know if we're going to see it well, but you can see here, I have my game master running. Oh, that's good. You can see that it's calling another agent, it's calling the character agent here, which is actually creating a object in the database, inserting it, and then sending back the information to my game master. It's not a big deal if you don't see properly. You can see that things happen. That's what's important. And you can see that I have an object that has a response, that has the dice roll, that has the details, that the object that we had before. And if I go back to, let's make this easier. If I go back to my game here, I have my game running. So I have like my character, John, with the characteristics. Welcome to the room, John. Your keen eyes adjust to the dapple sunlight, firing, blah, blah, blah. So you have a story. And actually, if I look at what happened in the network here, this is the tick, 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 the response I got. And you can see in the response, I have the response, so the narrative. I have the dice rolls. We didn't roll any dice here. And I have action suggestions, so I can have here. So I can say, you know what? You can investigate the sounds from the undergrowth, whatever it says. And again, it's going to, oh, it's rolling dice this time. And so it's going to come up with a story, and then, again, reply to me, say, okay, John steps forward eagerly, but his foot catches hidden, blah, blah, blah. I roll the dice to perception check to investigate, so I probably failed that. But you can see that because it's a JSON that I received, because of the structural output, I can have the dice that it rolled, the result, and the reason why it rolled. And again, based on the story it generated, it gave me some options of things I can do after, or you can just like run home. I can write, and then I can literally play the game. And again, when I do that, it's calling here, it's rolling a dice again, and then it's generating the story, and then it's going to send me back a story, the dice. Athletic check to flee quickly through the forest, 19, pretty cool. And I can continue playing like that over and over. And we are right on time. Done. You can go on the repository here. These are code samples for Strands. There's a lot of things we haven't covered. We just saw like how to create agents, collaborate, but you can have swarms of agents, graphs, and just make nodes and things like that. You can have workflows of agents, so many things.
Also, if you have a real use case with your company, as Olivier showed, like there's the story output, but there's so many other ways you can render the answer of your agent more efficient and more standardized. So you can actually really use those outputs into your applications.
Yeah. Go see the doc. There's many things in the doc.
Yes.
Thanks.
Do we have time for questions or?
Why not?
Thank you.